So thanks for coming, everybody, today. It's my pleasure to introduce Dawen Liang, who you know from a previous Laplace's Demon webinar, and he probably needs no introduction, but I'll give you a very brief one anyway. He's currently a research scientist at Netflix, and before that was working at Columbia doing Bayesian machine learning, latent variable models with Dan Ellis and David Bly. And something you reminded me yesterday, and I didn't pay enough attention to you before that you studied music technology, which is a little bit of a different path into these things. So thanks for doing this. I think it's going to be fun, and I hope you're opinionated in the morning because we're looking for some spicy takes to get everybody excited, or even disagreement is also good.
I'm probably more opinionated in the morning because I'm grumpy and also lack of sleep.
I'm opinionated, but maybe not in the morning. So to get started, I mean, maybe it'd be interesting to give a bit of background about how you got to become a research scientist at Netflix, doing recommendation and your journey, what interests you, etc. And
Okay. Yeah, I mean, like you find out yesterday, yes, I guess so I think I started like undergrad with a computer science major, but I was also very much into music. Like at one point, being a professional musician was seriously one of the possible career options. I mean, in my early youth, um, and so then during undergrad, I was being exposed to this field called computer music, which also has kind of a close sibling, which is called music information retrieval. At the time, I wasn't really sure what I wanted, but then I went to grad school at Carnegie Mellon doing music technology, which is, it's like, seems to be the perfect marriage between my major computer science and also my love, which is music. Um, but deep down, I feel like during my like grad school at Carnegie Mellon, I started to kind of feel like I actually find the the computation, the machine learning side of things seem to be more interesting, and that's when I also, I guess, and also kind of selfish reason is I would like to build a machine learning model that can recommend me good music, and I was thinking, well, of course I'm gonna use my music background, content-based signal processing, that kind of stuff. That of course that will help me find better music. As naive as I was at the time, so I was also start working on recommend the system and stuff, trying to get a little bit more exposure on that, and with the hope that by combining my music knowledge and also whatever is going on with recommend the system at the time would be able to find better music than at the time. Actually, I don't think there was any actual, like there was no Spotify. I don't know if I probably tried Pandora at the time. It was okay, but um, I probably have very particular taste, so maybe I want to build my own. But then, that's kind of what led me to work more on recommended systems, and also, as you probably all know, like eventually I also realized, okay, actually the content-based thing doesn't really help that much. Collaborative filtering is all you need, which is a little bit of a downer.
I was about to,
But
when you said naive, I was saying, is that naive or is that insightful? When you were like ahead of your time, sometimes it's hard to tell. Um,
well, um, I think it's still true that when you have a lot of interaction data, collaborative filtering is all you need. Like what I would, I guess by collaborative filtering, I basically mean those like model that don't really care what the content you're recommending. It's just you just need a user item matrix. That's all you need.
right.
So that's, I guess that's what I meant by yes.
I
But
think
yeah,
it's a
so
good thing
basically
to
that,
define it, but that's how I think of it too.
yes. I think content definitely has its use in some cases, but in the general, recommended system, like when people think about the general recommended system, we're not necessarily about cold starting or about some other specific area, I think that's still, the pure user item matrix based collaborative model is still, I think, the best. And yeah, and I think, but yeah, basically, I guess from the second half of my PhD, I started focusing more and more on general recommender systems, and which led me to my job at Netflix right now, and has been here for quite a while.
Okay. That's an interesting story. So what type of music did you play, or what instrument did you play?
Well, I mean, when I was a kid, I studied like classical music, piano, and that kind of stuff. But later, I kind of got lured into more exotic stuff, and I learned some other instruments as well, but not definitely not as deeply as classical music. But I kind of also branched out into all kinds of other genres. But yeah.
Okay, okay, interesting. I made jokes at Criteo about the like 12 tone scales and this sort of stuff, and then I made it to the wrong people that were like starting to talk about I like the science of chords and whether they should be the chord should be perfect or the interval between the notes should be perfect, and they started to talk about Chopin and things, and I was like, I'm way out of my depth here. I can maybe talk
Okay.
about science, but music, I have very limited ability to talk. But it's a really interesting path in, and so you were more in the. Well, it sounds like you were both into the signal processing and the recommendation part when you start to think about music. It wasn't.
Yes, I'm actually thinking about to combine them, because I was like, of course, knowing music, like I said, naive as I was, I thought, well, knowing music probably better than an average human being who works on recommended system. I thought this will give me an edge, but
Yeah.
turns
Okay.
out not really. And also because most of the people who work on like music information retrieval will probably share a very similar background to me. A lot of them are probably even more serious musicians than I am. So
Right. Yeah. There's always someone better in music, I think. But
yes, that's also part of the reason I never pursued that route, because it's like a very brutal word, and my parents my parents probably know a little bit more about that than I did when I was young, and my grades was pretty good, so they were like, okay, you should probably pursue a more
you
regular,
can do something else.
normal.
Well, I mean, the
Yes.
good news is that in the current era, you can also find fame in machine learning. So that's at least theoretically possible. Who would have thought uh, back a decade ago? Um, and you brought up, I guess, the two, but I think there's a third reco signal which we should also talk about. You'd like there's content, there's collaborative filtering, and there's some kind of bandit or user feedback signal. And
Yes.
we should talk about the trade-offs between them at some point. But
Okay.
um, so something I really liked in your talks is you'll often talk about the shift between research and academic research, let's say, and industry, and bring in. I think there's something, at least some Bayesians, and I'm particularly guilty of this, are purists in some perspective, some sense, and how this lives in industry. So, do we need Bayes in industry? Do recommender systems need Bayes? Or should we? Is it just a tool? What's your take on this?
Uh, I'm gonna say probably we don't need it as much as we hope. Um, in the sense that, um, well, I think this also goes back to, I probably talked about this in the, I guess, the seminar talk, but maybe not everyone here know about it. But I really like this term secular Bayesian, which basically means you were Bayesian at one point, but then later you realize there is a bigger word than Bayesian, but you still did not forget your Bayesian roots. And sometimes it's useful. And so basically what I mean by that is, I think, yes, like I started, of course, being very Bayesian because I thought that's like the natural way to think about problems. Like you think about how your data is generated, and then you build a model on it, and then you make prediction with your learned model, taking uncertainty into account. That seems just like natural. Um, but I think and also, that's also part of the reason I work with Dave, like who, is also very into this Bayesian thing. Well, at least back at the time. Um, and but I think the challenge is, um, it's nice to think about this on paper, but in reality, when you actually want to, do something with it, the complexity that comes with it often makes either you have to take a very huge compromise at how well you can do inference, um, and or you take no compromise, and then you end up being in a place where you can do really nothing practical. And I think that's one aspect. The other aspect is, I guess what I like to call the the I mean the old saying, all models are wrong, some are useful, but whenever you invite a model into your problem, like I think a lot of the stuff that's good about Bayesian is like, okay, assume my model is correct, which I think realistic in a lot of the interesting problems, challenging problems, that's probably almost never the case. I think in some cases that's definitely true. Like if you work on some, simulation where you know the underlying physics, underlying dynamics of the phenomena, then of course you can build a perfect model. That model is perfect. And then in that case, that's perfectly fine. But in a lot of cases, you are thinking about the modeling the complex user behavior of a human being, which I don't even know if you can, model it. Then the best you can do is how the best your model is able to achieve, which is very limited. But then you make a decision based on that, then I'm not sure if that's actually more helpful or not helpful. So, but having said that, I think a good thing about what I like to call the secular Bayesian is that the way of thinking about problem from like a probabilistic way or from a statistical way, I think I don't know actually how much that is still being valued in the current era of deep learning and LLM. But I would still like to think a lot of times that seems to give me a rather fresh and slightly different perspective on many problems. And that's something that I think this probably benefited me more over the years, like having this, different perspective that probably has benefited more over the years, especially over the last few years than whatever I actually did with all the Bayesian machine learning stuff.
It's the discipline and the way of looking at it that was more beneficial.
Yes, I think I can actually, I don't know if you want to hear an example. I actually have a recent
Please.
example that I'm actually very, I feel very good about that, which is, so last summer I had an intern, Alex Yup, who is a theoretical reinforcement learning PhD student from University of Alberta, working with Chaba, who is like technically a mathematician, and we work on that. Well, I mean, mostly he did most of the work, of course, and eventually it led to us to thinking about the loss function for like Q length, like what's called fitted Q iteration, which is basically a offline version of Q learning. And our eventual conclusion is, okay, you should. So the standard way of doing things is to use like if you look at Q learning, you normally just look at the square loss. Like you have your target, you have prediction, and you minimize the square loss. But what our project is about is basically saying, okay, rather than thinking about square laws, you should really think in terms of a binary cross entropy, as opposed to, think about that as almost like think about it as a classification problem as opposed to a regression problem. And one of the reasons why this is good from a very intuitive point is because if you think about this as like a regression problem, even though normally when we do regression, we are mostly actually always often doing regression with a fixed variance, homoscedastic regression, which basically means you're not taking the variance information into account. But if you think about minimizing your objective with a binary cross entropy, so I'm omitting a lot of details here. I'm actually mostly just talking about the actual binary cross entropy, not the loss you use in logistic regression. But in that case, you can interpret that as like doing maximum likelihood with a Bernoulli random variable as your data generating distribution. And the good thing about Bernoulli is if you're estimating the mean, you automatically know the variance.
Yes.
So the variance information is automatically baked into your objective. And in optimization, a lot of the time, not only optimization, I think a lot of problems in RL and bandits, having the variance is a very good thing. And so this is almost like you get the variance for free. Of course, that doesn't mean it's always helpful. So we show that, okay, under certain conditions, like for example, if you are very certain at certain points in the region, that can speed up your learning very significantly. And I really like this, alternative interpretation of thinking about, Gaussian likelihood versus Bernoulli, which is something that mostly, from me, like I guess that's one of my limited contribution to this work, because Alex did all the actual proof, like working through the whiteboard, getting all the proof to work through. But then I was like, okay, right. I think this is an interesting way to think about the problem, and that's also kind of led to some current ongoing work that he and I worked on over this summer, and has even more probabilistic interpretation behind it. So that's kind of a very recent example of mine, and I feel very happy about that.
Okay. I mean, the purist in me is saying I'm not sure this is really maximum likelihood with Q-learning, but I can see there's a connection here.
Yeah, I think if you want to be a little bit purist, I mean, the same result holds for bandits, where it really becomes a regression problem.
Right.
I'm
happier there. Yeah.
Okay.
Yeah, for sure. Because the Q is an expectation, I think. Yeah.
It
Over
is
some kind of model or something rolling forward. That's I think really doing Bayes and RL together is very difficult. Anyway.
Yeah.
To do it in a purist way, let's say. By the way, do you feel like not understood sometimes when you're like running the Bayesian way of thinking in your mind, and you're talking with other people, and they're like going, like, "What we're going to do," what you get a lot in Reco is like, "Well, we're going to create this loss, and then we'll create another loss with negative sampling like this, and we'll sum them together, and we'll do." How do you process that type of thinking with your Bayesian brain, or do you not do it?
It's so I think I think over the last few years, I definitely have spent more time thinking about bandits and RL more than Bayes, especially when it comes to thinking about objectives. And I agree. I think a lot of time, yes, I think that oftentimes the problem boils down to, okay, what loss function we use. And I mean, I don't know. I feel like in general, my impression is people doesn't seem to care a lot about the specific loss they use in industry. It's like, well,
that's definitely the feeling I get as well. It's just, let's just change loss. or use a ranking loss or another loss, and my brain is going, "Well, what are you doing now?" These are not the same things. But then there's also, well, it seems to be working, and
Yeah, yeah.
yeah.
It's definitely working to extent, and so I'm not surprised why it is what it is. Um, I so that's also, I guess, why I have mostly spent a lot of time thinking about, bandits and RL and that kind of stuff. Because to me, I think if you work on recommender systems, but not think from this, you know, reward optimization, policy optimization perspective, that to me is very odd. Because like if you think about recommender systems, you as the system, you are fundamentally are interacting with uh, your user, which quote unquote the environment. You you present something from your own decision, which is your policy, and then you observe some return, which is whatever user's feedback is, and then your goal is over the distribution of your users population, maximize some kind of expected return or some other function. It doesn't have to be expectation. It could be some quantile or something. I don't know. It's like up to you. But this way of thinking about, finding a policy such that you can get better return, good return, it seems like, that should be the fundamental problem for recommender systems. That's like, I think this is like a
I
lot of
couldn't
problem
agree
fits into
more.
this paradigm. And recommendation is especially so. And if you think about, yes, like, and also if you think about from this perspective, it should be pretty obvious what objective you should be using. I mean, I'm not saying there is only like one objective, but I think this general framing of this problem of recommendation, it seemed to me is like a pretty obvious thing. And that's also why I have, spent a lot of time thinking in this from this angle. Um, but I guess, yeah, I mean, I cannot convince everyone, I guess.
Really? Okay. I also would like to convince everyone of this, and I would go slightly further. I would say that it's really important to measure this with a proper user level split at A/B test time.
Yeah, that's true. I think maybe that's getting a little bit ahead of ourselves, but yes, I think, you know, if you think about it, like on a high level, that's how we think about the problem. But then as you go down the path, there are more and more things you need to worry about. But I think at least on a high level, I hope in a ideal world, we should all agree on this should be the problem that we work on, the problem we care about. And once we establish that, I think we are on a common ground.
That's
We have a common ground, and then we can start doing all the other things. Because it's not like having this objective solves everything. It's actually that's just the beginning.
I
And then
couldn't
you need
agree
to,
more, actually. This is music to my ears in so many ways.
okay.
Yeah, and I sometimes feel a bit. I mean, in industry, it's probably not such a hard sell, but the academic world doesn't recognize this to the degree I would like. And I think Phil, that you're saying something similar.
Well, I mean, I don't even know about industry either. It's I think a lot of people would agree, but but is that strong enough to convince them to actually? Because I think also because um, this is probably me. I have like this is not only about Netflix. Actually, what I said, what I'm going to say doesn't specifically apply to Netflix because I also, interned at some other companies in the past, and I of course also heard talking to other people from other companies, and actually a lot of the observation I had are pretty, universally shared. But I think I'm gonna make a educated observation, which is that recommended systems, a lot of the successful commercial recommended systems were probably built around the time when Netflix price was still the dominant way of thinking about recommendation, or at least maybe not immediately at the time, but at least immediately after that. So that's still one. We think about recommender system as like almost like a supervised learning problem. Like you have a data and you try to fit a model to best explain that data. That kind of thinking, which is slightly different from if you think about this from like a optimization, like a reward optimization perspective. And because of that, a lot of the base version of the models in a lot of the commercial recommender systems are probably built with a very different goal in mind. And as you probably know, as you work in industry, like once you have something, it's not very easy to completely scratch that and change it to something else.
I
So
I mean,
yes, so that
I don't usually say this. I'm in enthusiastic agreement, actually. And an additional force that drives this actually is if you're trying to build a system and you don't have any users to start off with, you have no choice but to do this, actually.
well, so I'm not sure. I think,
As in, you have no bandit feedback at some in an early
well, yeah,
stage.
you need some feedback, but like, let's say you want to train a classical model with no feedback, you still cannot do anything. I think that's also what the part of the equation which is missing. I mean, which is the part that I didn't talk about, which is, I think once we agree on that objective, and then the next question is, yes, I think a very important next question is, where does your data come from? How do you collect your data? Does your data have enough exploration, or all the other fun stuff? Is your data, are you gonna able to, I guess, control your exploration or not? Or are you gonna train on your, like, the data generated by your own policy or a different policy? That all kind of the problem comes into play. And then, but again, that shouldn't stop you from thinking about that objective.
I agree completely. Actually, I slightly want to map back to something you said earlier, which I think is only an apparent contradiction, but I want to mention it because you start off actually saying collaborative filtering is great.
Mm-hmm.
And in some ways we've now, which is, I think collaborative filtering, I agree with you. It was massively influenced by the Netflix prize
Mm-hmm.
and sections of, well, some people let's say they equate collaborative filtering, recommender systems, and the Netflix/movie lens as all the same
Mm-hmm.
area.
Yes.
Um, and
Okay.
but then,
Yeah.
so you said this was very good, and one of your very nice contributions is the multi-VAE on this topic. But then how do you marry this with the fact you said, well, actually, you're thinking about this more causal view of things.
So yes, that's a good point. I think I would say that whenever I say so, um, I think there are probably maybe two slight different perspectives here. One is that I like to think about a lot of those, which I call the, the f of x scan, which basically means I don't really care about what my model actually is. I just think about it as f of x. Like x is my input, and I have a function which maps my input to some output. What that f should be, I don't care. And if you think from this perspective, um, when I say collaborative filtering,
You
I
you
mostly
mean you
meant,
mean ERM now, like empirical risk minimization and
oh, no,
FC?
no, no, I'm not even talking about objective. I'm just talking about a function that's
Yeah.
like I have some input, and I build a function f, which gave me some output. And then I have some target, and then I have a loss.
Okay.
So to me, I think when I say collaborative filtering, I actually mostly meant the kind of model that use user interaction data. Of course, so for example, you can think of VAE as one of the possible options for f of x. And another possible f of x is matrix factorization. Another possible f of x is like the ease model that my colleague at Netflix, Harold, worked on. To me, I don't care what f of x you use, because some of f of x is probably good for you at a particular problem. Some of f of x is probably good for you at another problem, and I don't mind whatever f of x you use, and I hope you have a way to optimize for it. But to me, what's more interesting is what comes down the funnel. Like after you decide you have this f of x and you have a target that you want to optimize, and then what's more important is like what's your objective that helps you optimize for your ultimate goal. And as a byproduct, you also need to learn your f of x, but the f of x can be really anything. So I guess and this also helps me a lot when I think, especially working with complex system industry, where a lot of the time I don't even know what f of x is, but I don't care. I just trust you gave me a good f of x, and I'm just gonna work on top of that, and hopefully thing works.
Can I rephrase
Yes.
just to check I know what you mean, because I'm not
Yes.
totally sure. So I mean, I think it sounds like maybe you're talking about two-stage systems where something like collaborative filtering is used to produce embeddings, and then there's a second stage that's a bandit stage, which I think is an industry convention. Is that?
Not necessarily. I'm actually just talking about it could be just like one model. I'm just talking about like if you think about, let's just think about the very simple way of thinking about like let's just think about the classical collaborative filtering. Like for example, VAE. You have some input data, and then you pass that through a neural network, and in the last layer you get some output, which right now let's just assume it's some logit. So that is what I mean by f of x.
Okay.
But then after that, you will have an objective function, right? And those two parts are completely independent of each other. You can have an objective function works on any arbitrary f of x, and you can swap your f of x. Like for example, you can just take your VAE, throw it away, and plug in a matrix factorization, and you still have the same objective function, and nothing should really change. Of course, the performance will be different because the f of x itself matters. But my point is, I think I don't really care too much about what f of x you use. Like you can also take out the f of x and use like some other, I don't know, linear function or nonlinear function, or like the ease or whatever. Of course, the choice of f of x also depends on what input data you have. If you have different kind of input data, maybe you want to design a different f of x. But again, I think I try to leave out of the picture of how f of x is actually being decided. And I'm mostly thinking about, okay, now I have this supposedly a function. I'm gonna actually come up with an objective that leads us to somewhere.
And this is now when you're thinking more of a bandit, this objective is potentially a bandit or something similar.
Well, yeah, I would love this objective to be some kind of bandit, but again, like even the classical way of thinking about recommended system also fits in this paradigm. It's just like that's not the paradigm that I necessarily agree on. But again, like I think this way of thinking also helped me, separate out two very different components. Like because the first f of x part is also has more to do with like architecture engineering, feature engineering, that kind of stuff, which is of course important, but it's not something that I personally spend a lot of time on.
Well, you did build an innovative multi-VAE model that I guess is as a possible f of x, but it's
Yes, that's one of the possible f of x. But again, I think I have said this multiple times to you and to other people. I've moved on.
okay, enough of the multi-VAE. We'll but so okay, let's talk about the bandit part then, which
Yes,
is what's your take of I said IPS, but maybe you'd prefer to call it off-policy estimators or
yes,
Hobbit-Thompson estimators versus using the direct method. From my viewpoint of view, the only way to be Bayesian here is to use the direct method. And a
yes,
lot of these papers very quickly just say the direct method is bad, and then that's it. And then they go off in another direction. Is the direct method just bad and shouldn't be used? Is it a problem to be using Bayes, in these causal problems?
I I'm gonna also I think it's gonna say something that you probably don't like. I would
Please.
partially agree. Uh, I think, and also what's even more interesting is when you do direct method, it doesn't have to be Bayes. Actually, most of the direct method has nothing to do with Bayes, unless you call maximum likelihood Bayes, which
No,
I
I
don't
agree.
think
I
you do.
agree. It should be.
So,
Yeah.
um, so I guess here's my again completely non-rigorous argument, which is I think I think direct method certainly has its use, but a lot of time I think especially um, in like a recommended system setting, I often find that direct method is trying to take a detour and solve a more difficult problem than you actually need to solve, in the sense that like estimating expected reward is, especially when your reward is often tiny with a lot of noise, is probably more difficult than if you say, okay, I'm just gonna do policy optimization, like just parameterize your policy, directly optimize the parameter of your policy, as opposed to train a model that's give you reward prediction and then you take argmax or sort it
Yeah.
somehow.
We probably should have just explained the two ideas for people that are not familiar with it. So I'll try and you can correct me if I do a bad job.
Okay.
So direct method, you have a context. You have all of these problems are contextual bandits, which are you have many realizations of a context, which tells you what the user's interested in if it's a recommended system, an action, which is a recommendation, and a reward. And realistically, that's a click. It's very hard for it not to be a click. And if you do the direct method, you cross the context with the action and try to predict the reward. That's how you build the model. But when you deploy the model, that you then have the context and you find the best action for that gives the highest expected reward. And Dawen is pointing out that if you don't have a log of many actions, it's very hard to estimate this. The alternative methods is that you have a policy or a decision rule, which is just a mapping from the context. So that's the interest straight to the recommendation. And then you can compute expectations, expected utility, expected reward of this using a non-Bayesian estimator, which I always feel uncomfortable with, which it's involved, so it involves an integral over the context, but it's a simpler thing, I think. How did I do?
I think pretty spot on.
That's
I
reasonable.
guess I would just one minor thing, which is I think another problem was I think for direct method, I think it could actually work. I think a lot of cases that's really all you need. I think um, at least to start with. I think a good direct method is probably all you need if you have nothing. But I think the challenge is a lot of time when we think about direct method, um, it depends on the quantity we are trying to predict. Like if that quantity itself is often small, which is the case for a lot of the recommendation scenarios,
The
which is
clicks, it's usually very small, yes.
yeah. So
Advertisements are
if you
very
are
small.
if you have a very small prediction, sorry, if you have a very small target, but also a lot of noise around it, then if that's actually where being Bayes is probably can help you, which is because if you don't properly taking into account about those uncertainties and then just take your prediction as like a point estimate and then you sort them, a lot of the time you are basically just sorting noise.
I again agree. And I think maximum
Yes.
likelihood can be terrible here. So I think direct method with maximum likelihood is not a good idea. But I'm a very boring and persistent promoter of Bayes here to do things like assume that the effect size is very small, that it's probably similar for all actions and things like this. And picking up on your point that it's doing so it's doing kind of doing something harder than it may seem necessary because you have to estimate reward for everything. And if you
Yes.
estimate reward high randomly somewhere, it's a big problem.
Yes, especially when you don't have, because I think direct method works perfectly if you have perfect coverage. Like if you actually, completely explore the entire state and action space, then direct method is probably the best you can get. Um, but the realistic challenges in any realistically interesting problems, you probably are nowhere nearly exploring your entire space. And then that basically means if you encounter a space where part of the region where you have a lot of very little data support, you really depend on your model to extrapolate. And we know how model can extrapolate very terribly bad sometimes. So basically, and then you take argmax, you are basically just picking that.
Okay, all this is of course true, and I mean and both because there's an explore exploit, so you're probably not doing crazy bad actions, and there's almost an
Yeah,
idea you would need to do this if you're especially using maximum likelihood. But even just the space is too big, which is also usually true. Um,
yeah.
but okay, I have to do my but.
Okay.
The IPS methods are integrating out. They're a decision rule that maps the X to an action or a policy. It's usually called a policy. I think it's the same thing, more or less.
Yes. Yes.
Um, and it's integrating out over X, which is complicated and hard to do, and it isn't necessary. And so I would say they are also doing something unnecessary. It's just in a different place.
Well, I guess I'm also trying to clarify what you mean by integrate over X. I guess because to me, integrating over X is really just because you need to have a single number, a scalar that tells you, how good the policy is. You need to integrate over everything. You need to integrate over your action. And then you also need to integrate over your context, which in a lot of cases, realistically, that really just means take all your data and sum over everything.
I don't think you need to. I mean, my argument would be you don't need to. This is an average, it's an expected utility averaged over all X's. It's not, in my view, necessary
Okay.
because in order to do a good recommendation, you only need to know the best action for every context. You still don't know what the average utility would be, but you can
Mm-hmm.
still, it's still sufficient. You can, some of the problems, the so-called problems of the direct method come from integrating out under the X, which you don't need to
Mm-hmm.
do to actually deliver the recommendations.
Okay. I mean, I think even for, policy-based method, I think a lot of the time, I guess to me, I often like to think how two things are similar, I suppose how two things are different, which I also find that quite interesting because especially talking to, more recent like grad students, they seem to be completely on the other way, which is like when they see a paper, they just like to think how this is different from the other thing, which my hypothesis is because the way how currently you have to write paper, you have to tell your thing is completely different from everything else that has been done before. Otherwise, your paper will get brutally rejected. But I find this mindset not very helpful because I like a lot of the time when I think about like look at different problems, different approaches, fundamentally they share a lot of similarities, and they are not that different, and that's true. I mean, scientific progress is practically stochastic gradient descent. So I find it ironic that when we rely so much on stochastic gradient descent, both within the project and also as scientific as a field, like we rely so much on stochastic gradient descent, but then we also kind of frown upon the incremental change we made to the anyway. It's my rant about the review and stuff, but anyway.
I agree with, actually, I disagree with quite a lot.
Okay.
My main point of disagreement is, so of course you have to claim probably more innovation that's healthy, and so your method has to be somehow different to others. But there is a tendency to say my paper builds upon all of these methods and lists them all, and they can even be inconsistent with each other. And okay, I take it a little bit of a different. I somehow agree with the SGD analogy, but in the sense of we take lots of steps in the wrong way. And so lots of papers are wrong and going the wrong way, and that's okay. But
Oh yeah, I'm not saying every paper is taking in the right direction, but I mean, again,
yeah,
that's the beauty of stochastic gradient design, which is you don't have to always take the right way. And
yeah,
also it's a noisy aggregate of many individual gradients. So
okay, okay. Um, well, talking about something that you probably isn't part in the past. So, do you want to a little bit talk about the convolution estimator? And I'll let you give a chance to share why it's cool, and I'll try to defend the direct method uh, as a possible approach here. But
okay.
um,
I mean, I guess it's hard to just say why it's cool without any context, but I guess the context is often the context as in the actual context, not context in bandit, but um it so I think so that particular work is so I mean now we're gonna specifically talk about like the IPSS method, which I know you are not a big fan of, but um I think
the industry loves, and the academia, like it's many contributions are occurring using this estimator. So it's
well maybe the reason is because it has the obvious hole that everyone wants to fill. Um which so basically like the IPSS estimator on paper it's like perfect. It's like it really, you just do importance sampling. You have a data coming from one distribution. You want to pretend it's coming from a different distribution. What do? You reweight. It's like such an elegant and simple method, and it should just always work. But the reality is, it often never work. It if you have like realistically sized context space or realistically sized action space, because the variance will come in and bite you. So I mean the policy convolution idea is actually pretty straightforward. Like because the reason you have large variance is because when you do IPS estimation, you have this probability ratio of the policy that you are trying to estimate in pi over the logging policy, let's just call mu. So it's like you have this ratio. If this ratio takes largely diverse value, some really large, some really small, that hurts your variance. And so really the policy convolution is basically trying to kind of almost like group up some actions together in one way or the other through quote unquote convolution. And then so in some sense you make your action space smaller in a, I guess maybe you can say a principled way, like by looking at the similarities between different actions.
using
And
action
then
embeddings.
yes, action embedding is one way to think about that. You can actually, in the paper, we actually have one case where you think about action being a node in a tree. So it's like more like a hierarchical structure of action, which doesn't necessarily mean an embedding, or unless you say that's a binary embedding based on where it is in the tree. But anyway, I think it's just trying to make use of some innate structure in your action space to kind of rethink about how you divide your space so that you are less likely going to have extreme value at your like importance ratio. And it turns out, not surprisingly, you are making, in some cases you can make a much better bias versus variance trade-off than the vanilla IPS. But I think that's kind of the high level idea.
Yeah, and I think that's was, and I agree totally with the many IPS estimators because they have this ratio in them, and there's a whole bunch of papers about changing the ratio in some way, clipping it or doing something with it.
Mm-hmm.
And I think of this as very blunt, and this is to me is a much better direction of like, okay, if you're to have group different recommendations together is far more, I think, in a practical sense, beneficial. I do think the amount of academic, I'd be curious on your take on this, but the amount of academic interest in these estimators suggests that they're being used all the time in industry. And I don't think they're used much in industry at all. They can be in very narrow situations used.
Mhm.
Is that
Yeah, I mean, again, I certainly don't have a full knowledge of the entire industry, but from what I can gather, I would say I agree. I think I mean, again, yes, I can see a lot of academic interest in this particular domain, but that doesn't necessarily mean, you know, this is something that is being, actively used. I mean, that's a big part of academia, which is they don't really care, right? Like if they are used or not, if it's an interesting problem that they can work on, they work on it.
Yeah, no, I think that's fair. There is some use of it, I would agree, but I mean, reasons why is that the action space is usually much bigger than you see in academic papers. So, like a lot of papers
Yeah,
would say turn a supervised learning problem into a bandit problem with a very big treatment effect in a very small action space,
right.
and
But
nothing on the user timeline, etc. And so many additions are including that I think cannot be
but
handled.
actually, I agree, but I'm also going to offer a counter argument, which is I think sometimes we are kind of blinded by the problem that we work on, and we think every problem is the problem that we work on. Like,
Yes.
yes, I think I agree. In recommended systems, a lot of the cases you have a gigantic action space. There's nothing really you can do with any IPS estimator. But actually, there are a lot other problems where that's not the issue. Like even within industry, like recommended system is just part of the industry. There are many other problems where taking a policy optimization, reward optimization perspective is very helpful. And still you can think of it as, you know, having a much smaller amount of options that you might need to choose from. And those are exactly the cases where I would say this kind of IPS estimator might actually be quite good and useful.
Uh, For sure, I think it's certainly lower assumptions than a modeling approach, which the direct method requires. And um, okay, I'll be slightly conciliatory on this estimator.
I mean, I'm not biggest fan of the IPS estimator either. So
It's actually I don't know if you followed it, but it's one of the subjects of the Christmas sim. Yeah, of course you did because you were involved in the workshop we ran in 21 where we had Larry
mm,
Wasserman and Christopher Sims were essentially arguing about this estimator. And I mean one issue with it is it violates the conditionality principle. I found neither of them said. I think I agree with Larry Wasserman on this point. Christopher Sims, I didn't think gave a correct answer, as a direct answer to whether it did or not. But the propensity score is the probability you would do an action when in fact that action what the action you did is known. And so the conditionality principle says you ought to use the action you did rather than the average action you would do. And
yeah, I mean, I think if you
it's an academic point.
if you really think about those like technicality, I don't think there is a lot of things that we can do. But again, fundamentally, I think to me, regardless of what you do, often I find that if you basically need to also write down a list of assumptions, and then I guess you should always cross check each assumption with the problem that you work on, and maybe you realize, okay, these are probably wrong. But I guess the good thing about thinking from this perspective is, if all the assumptions are being met, then things should work.
True.
So if it didn't work, you can just go back and check your assumptions. As opposed to if you don't know, if you design your objective or design your system in a more arbitrary way, then really when something goes wrong, which they will, I mean, of course they will go wrong, you don't really know what to fix. You can just have to randomly making hypotheses as to, okay, why, maybe because that, because this, and then okay, makes this change. Yeah, so
Yeah, it makes sense. We're actually we're getting done to time almost immediately. If anyone has any
Okay,
questions that I'd like to ask Dawen, go ahead. But we should also talk about you because you've jumped on the LLM bandwagon. Do you want to tell us all a bit
okay,
about this?
yes.
What's
Um,
where do LLMs and Rexes fit together? Are they?
uh, I mean, yeah, so
You talk
I
about
think to
what
me,
conversational recommendation. Maybe you should. You've done some work on this. What exactly is that?
well, so I mean, conversation recommendations is as its name suggests, it's like you you converse with the recommended systems in a natural language format, and then you hope to get good recommendation. It's really like a different way of interfacing with a recommended system. Um,
So
I think yes,
I mean, it actually strikes me that's in some ways quite a big change because if you're on Netflix, you get recommendations just shown at you. There's no, that's just part of the system.
yes,
And same with the computational advertising.
hmm
This is like, oh, I'm deciding to use the recommender system. Is that
yes. So yeah, I think it might appear more at or I guess you can say a retrieval slash search use case. But I think also for conversation recommendation, it's also the line is much blurrier in the sense that you can of course use a conversational recommendation to do retrieval. Like I just want to watch that movie, which I cannot remember, but I remember some vague plot points or something about a particular movie, and I can just ask, okay, which is how we probably use ChatGPT these days. Um, but then another aspect of this is we can actually, just converse it almost like a recommended system. So not necessarily retrieval, but more like a recommendation, which is like, for example, you can say, um, I like movie A and B. Give me something similar to those. But maybe you can also say, but I don't like certain aspect of movie A or certain aspect of movie B, or I want more of certain aspect of movie A, some aspect of movie B. Then, the combination is infinite. And what's really interesting with LLM is, I think, until the emergence of LLM, I find it's really hard to understand like free text form. Like if you just what I just said, like a bunch of things, like any pre-LLM model would have a hard time, turn from what I just said to anything sensible.
yes?
But LM is like, yeah, you can basically just go to GPT-4, type in what I just said, and subbing actual movies and actual aspect. GPT will give you sensible results, which is, I think, in some sense, amazing because it's like it just happened to know,
It is mind blowing.
appears to know
Yeah.
everything. And actually, we did check. GPT literally knows everything. You can ask GPT to write movie descriptions. It can write better movie descriptions than anything you can find, anywhere you can find. And with more information and the more like, yes, a lot of the nuances that are not in, for example, in IMDb, it's definitely there. Yes.
It's sometimes
So,
dishonest, but
well, I mean, yeah, I think
I mean,
hallucination,
it
of
has the
course, is a big,
possibility to make a movie better than the actual movie is in the description. I think this could happen. Um,
that's a possibility. I think so. I think conversation recommendation is certainly like one aspect where like LM is certainly very useful, but I and also, I mean, some of my more recent papers are about conversation recommendations, but I think LM can actually also be used in the more general recommended systems, like not necessarily um, in a conversational setting. Because if you think about it, like LM is really a gigantic transformer. So yeah,
I mean, I
it's
think it gives you a very cheap and easy way to leverage content, if that's what you mean, in like item descriptions or things
yeah.
like that.
So I think another way of thinking about this is actually goes back to my very earliest point about content versus collaborative filtering. I kind of see like IOM is like a super powerful, all-knowing content recommender system, content-based recommender systems. it doesn't know the actual user interaction data. Or, I mean, it kind of knows it, but not specifically to a particular platform or specifically to you, unless you provide all your, viewing history, which you can do. But even in that case, you still don't know the underlying rationale why, like, I will, okay, based on your viewing history, give you this. You would love that to be a little bit maybe more transparent. And but yeah, basically, I think this is like, how to combine content-based with collaborative filtering-based has always been a challenge and also an ongoing evergreen problem in the recommended systems community. And I think now this problem has kind of seamlessly shifted to how do we combine LLM with collaborative filtering-based model? And that's something that I find also pretty fascinating.
Yeah, that's a very interesting direction. Also with the bandit case, also, I mean, I guess all it's a kind of machine learning tradition combined two different things, but it,
Yeah.
there you think of the most interesting directions for Rexis incorporating LLMs.
Well, I mean, I don't know if I don't know if it's the most interesting direction, but I think it's certainly one interesting direction that potentially can give us a very different experience. Because it's like this is probably the first time where you can quote unquote converse with a machine in
Yeah.
a like natural language. And I think that to me feels pretty huge. Like I think we are still trying to figure out, like I think we can all agree that LLMs are very useful. The question is actually how to make use of it. I think that's what everyone is trying to figure out.
Yeah, I think I feel like it's a topic I know very little about really, but it's mind-blowing what's been achieved. But also I think I haven't yet incorporated actually what's been achieved into what the research I do. I think even though the breakthrough is a couple of years old now, it's still unclear
Yeah.
to me.
The first thing you can try is to use the GitHub Copilot.
Okay, that's a good
Yes,
point. That's a good.
just yes, that's the perfect way to integrate into your work. I mean, right now I use like LLM basically as my replacement for Stack Overflow.
I I don't use it too much, but I concede it's pretty good at least at giving you boilerplate code. Um,
Oh yeah, more than boilerplate, I think you should try it. I think I probably have a more open mind than you have about all those things. But yeah, it's like
I actually I argue with LLMs. It's my argumentative nature is I can remember arguing with an LLM about whether it got the variational approximation right, for example, uh, and it
but I
always
think
apologizes profusely. So I guess it's okay.
yes, I think whenever LM does something stupid or something horribly wrong, you should always remember what it really does is to condition on what has been generated, generate the next token. It's not even next word, it's next token.
This,
So that's all it does. I mean, of course, on top of it, there is like, the human alignment. But again, fundamentally, it's a model that's just keep generating the next token. So don't, put too much pressure.
it is mind-blowing what it achieved. In fact, it got a one and n factor out, which was all it did. Is still mind-blowing. But actually, I feel like we're running out of time. But that's actually a topic I also wanted to raise with you. Is the user level, which is as measured by A/B test with the immediate, and we talked a bit before. Like basically, is it optimizing clicks? Is actually I think even the people that like bandit feedback. They for exactly the same reason as it occurs in LLMs. As far as I can tell, people pretty much optimize clicks or attributed
Mhm.
value to clicks. Do you use the term attribution in recommended systems like Netflix's or not so much?
I guess to clarify what you mean by attribution, do you mean like do we, like for example, I think in the Netflix case when we use the word attribution, we probably will think about like for example, if we observe a particular member like retain at the end of the month, how do we like attribute that to a particular thing that happened over the last month? I guess that's what I mean by attribution. I'm not
Yeah,
sure if that's what you
so
mean.
I can see on this area where we are in an easier position because if you're an
Hmm.
advertising company, you just want to make money for your client as a simple
Yes.
it's simple economic value. So
Yes.
what we mean is it is the same concept, is it? But we have sales that we would like to say, well, did
Yes.
the thing is the sale belongs to the user, but there are multiple recommendations or multiple things that were done to the user in the process. So
Okay.
I think it's the same.
I see. Yeah, I mean, we talk about attribution, but I think you can, as you can probably tell, we don't think too hard because it's impossible. Like, how can you attribute whether or not someone retain at the end of the month to a particular recommendation or particular, set of recommendation? It's likely a combination of everything that has happened in the last month, and a lot of which you do not observe.
Yeah.
So, yeah,
Yeah, I suppose you must have view time and things I'm not used to thinking about as well as click. That might
yes.
be, I
Yeah,
suppose,
I think
used in.
maybe also working at a subscription service company also makes me less, myopic about the objective because like click doesn't really matter much to us. But I can see, yes, it could be a,
Well,
yeah,
it
a
also
fundamental
doesn't matter
metric.
to us, but a sale is
Okay.
just so difficult to optimize for that.
Right, but I guess this is my very limited understanding of computational advertisement, which is yes, you want to optimize sale, but you cannot. So you optimize, click because assuming
And
certain
the industry builds on
portion of
clicks or
yeah, you
attribution to clicks.
certain portion of the clicks leads to purchase. So if more clicks means more money, right? I guess.
We do obviously at A/B test time we obviously are not doing clicks, but offline it's very difficult to target any other. It's we attribute sales to clicks, um,
Hmm.
but more long-term value I don't. Which someone always will want to do reinforcement learning. It's very difficult. Like it's of course we want to try, but it's very difficult. And
Yeah, I
to your
mean, we
point,
didn't even say the word like RL much, I guess, almost like by design. But yeah, I think it's anyway.
we didn't talk about many things, but maybe we should do it again. But I think we should wrap up because I think mostly people are going home.
Okay. Yeah, it's
Thanks.
probably already late in Europe, which also means
No,
I
it's not
need
too
to
bad. It's
actually.
only 6 o'clock. It's just early for
Okay.
you. I appreciate you.
But
Uh,
I thought Europeans say go well, I mean finish work at like I mean, they don't work, that's what I heard. Like they
I'm,
don't work and they have dinner at 9 and go to bed at I don't know. It's all a
um,
myth to me.
yeah, in French tech, I think it's start late, finish late type of pattern. I do agree with this. Um,
Okay. Yeah, I think it was fun. So I mean I'm fine to do this anytime, like offline, online, because I feel like this is basically what we do anyway. Like when we see each other, we just talk about those random things. It's just this time that happens online.
yeah,
Was
it would be nicer in person. We should maybe also try to do that. Um, cool. Well, thanks a lot. Congrats with the paper. Actually, maybe you should plug. You've got a paper at Rexus that's being presented in 2 weeks. Um,
oh okay, yes, that's true. There is a paper. I'm not gonna be there, unfortunately. But
what's
you
it
know.
called?
It's basically about conversational recommendations, and it's trying to make use of a pretty simple idea of like a neighborhood-based LLM. So it's like if you have a particular query and you want to know what people would say about a particular query, well, but sorry, you have a particular query you want to respond, and a pretty simple way to do that is to look at all the other queries that you have in your data set and find the neighbors, the closest neighbors, and see how these are responded. And then you responded in a weighted combinated way. And which couldn't be simpler. But the key here is if you do this, you are actually able to achieve very good performance with much, much smaller LLMs. Like, for example, we were able to achieve like relative comparable performance to like a very large model with like maybe 10% or even less than the size. And also smaller model means, faster generation and faster everything. So it's a neat like experiment that we were surprised to find how well it worked. So that's why we had this short paper Rexus about particular that.
Okay.
I don't know who will be presenting it because a lot of us were having either visa issue or scheduling issue, so we couldn't actually travel. But I heard someone is going to be there. So
Okay, I'll find out who it is because I'm actually able to go this time. Well, thanks again, and have a good day, and I'll be in touch about next time.
okay, yeah, sounds good. Thanks very
All right.
much.
Cheers.
Okay,
Thanks everyone for coming.
bye.
Bye.